It's going to be, I'm going to write En. Nico, I'm going to write En instead of electronegativity. I like short forms. I'm not lazy, I'm efficient. Okay, electronegativity. So just to review, this is the pull an atom has on a neighboring atom's electrons. So it's the pull an atom has. So it's that positive pull from the nucleus, right? If it's pulling on electrons, it's an attractive force. It is the positive pull from the nucleus, and it's pulling on a neighboring atom's electrons. So on the graph, you looked at the graph. Just trying to find mine. What did you notice about the trends for electronegativity in terms of groups? Who had the highest? Who had the lowest? Kathleen? Yeah. Noble gases. Group 18. Had the lowest value. It was 0. Right? It was 0. Why would they want to pull on somebody else's electrons? They're full. They don't need any more. Okay. Who had the highest electronegativity values? Where were the peaks? What elements were the peaks on? Isaiah?
17.
Yep. Halogens.
And alkali? You didn't say alkali.
Group 17 had the highest values. Who had the next lowest values above the noble gases? Sarah Era. Alkali metals. So the alkali metals, the group 1, also had the low values. They were the next lowest. Okay? What happens to the electronegativity values as you go down a group? What happened?
They go up.
Use
Go down.
use your values. Use your graph. They go down. Okay? There are reasons for this, and the reasons for this is the smaller their atom, the smaller the atom, the more control over the electrons. So the smaller you are, that means you're pulled closer to the nucleus, the more control that atom has over those electrons. So, halogens had the highest value. Out of all the elements that still want electrons, they're the smallest. Noble gases don't want any, so they don't have a value, but they are the smallest. Alkali metals, do they want electrons? Do they tend to gain or lose when they become ions? They tend to lose, so they're not going to pull anybody's electrons. They're trying to push theirs away. So the alkali metals have a low value because they really don't want them. And the reason they really don't want them, they're so big. They can't control them. Okay? So the smaller the atom, the more control they have over the electrons. Yeah. This is the energy associated with removing an electron from an atom. Who had the largest value? Okay, so noble gases had the highest ionization energy, so requires most energy to remove an electron. From the elements, from the element. What other trend did you notice? So, what else did you notice going up and down? Was there a trend? Moving down a group, ionization energy decreases. What happens to the ionization energy then as you go left to right? Look at the graph. What happens to the ionization energy left to right across the periodic table? Between lithium and neon, between sodium and argon. It increases. So moving left to right, across a period, ionization energy increases. Size determines how easy or hard it is to remove an electron. They were big. What happens is you move down a group. Do they get bigger or smaller? Going down a group.
Oh, bigger.
They get bigger. Left to right. They get smaller. So you can see the smaller you are, the higher the value. Okay? Size basically determines the other trends. Electronegativity, ionization energy, and the last one that I'm going to mention is electron affinity, but it's going to be really brief. We're going to be very brief on this one. It's called electron affinity. Short form, EA. Electron affinity is the energy associated with the addition of an electron. So it's the energy associated with the adding of an electron. So we're forming negative ions. So it's highest for the halogens. And the reason is they are smallest, therefore most control of added electrons. The smaller you are, the more control you have, because the more the positive pull is felt in the valence shell. Stella?
How come it's not the noble gases?
Because they don't want any.
They don't take electrons?
They don't take electrons, they're already full,
Oh, yeah.
right? But you know what? As I was writing that, I'm like, who's going to be smart enough to say, what about the noble gases, because they're smaller than the halogens?
Yeah, I was like, wait, I really don't want to. Cool.
So, that's all we're going to talk about in terms of electron affinity. Because some values are some values are positive, some values are negative. Okay? Ions have either, this is just a review, have either gained, stay with me just for a couple more minutes. Ions have either gained or lost electrons. If you have lost electrons, you are a cation. So these are your metals, right? These are your metals. When they lose electrons, they shrink in size. They are. So they have lost electrons. So cations become smaller than their atoms. And the reason is there's less electron-electron repulsion. So a sodium ion is smaller than a sodium atom. Right? It's lost that valence shell, basically. The more electrons you lose, the smaller you get. Your anions, your negative ions, so these are the non-metal ions, become bigger. So they get bigger than their atoms, and that's because there's more electron-electron repulsion. There's more electrons to be repelling, but the number of protons hasn't changed. So the positive pull hasn't changed, but the electrons are pushing themselves out because they're repelling. the more electrons you gain, the bigger you get.